G'day. In this video, we're going to be making a game. It's going to be a minesweeper clone, but we're going to put an Aussie twist on it. It's going to be a bit of a venomous minesweeper clone because we're going to be calling this one SnakeSpot. We're going to try and see if we can spot all the snakes that have infested our backyard. And we're going to be making use of some really useful Python features, especially things called sets. Sets are going to make our lives much easier as we write this game. Let's get started. So the first thing you're going to want to do, set up a new folder. I called my game SnakeSpot, and inside that folder you're going to have your Python file, which is this one, just a blank file at the moment. I just give them the same name, and I've got an images directory as well inside there because this game is going to have a couple of images, and I just got these from openclipart.org. I got this one to flag where I think there might be a snake, and I got this one to display a snake, which hopefully we'll never see, but when you play the game, if you click on the wrong spot, you might end up getting bitten by a snake and see this image. So let's get started. So let's go to our file and put in a quick header comment. So this is a minesweeper clone using snakes. If you've never played Minesweeper before, it's quite a fun game. Yeah, you should give it a go. But you'll be able to play it when we finish writing this file, or pretty much Minesweeper anyway. So we need quite a few things to make this game work. Well, not a few, not a lot, but a few. So we need the OS module. So we do import OS. We're even going to use the math module to use one of the functions out of that. We need Tkinter as well. And don't need that bit. Did it again. There we go. TTK as well. So from Tkinter. What else do we need? Yes, we're going to use the Python imaging library to manipulate those two images slightly so we get them the right size that we want them at. So from PIL, Python imaging library. So if you haven't installed that, it's called Pillow, P-I-L-L-O-W, and you need to install it using pip. We need image and image TK. So if you've never installed PIL or Pillow, you'd just go pip install Pillow, or if you're on Mac, you'd go pip3, or with Linux, you'd put pip3 down there. And then when you run that, so on Windows, this is a Windows machine, so I just put pip. When you run that, it'll download it. This one tells me it's already installed. But once you install Pillow, that'll give you access to the PIL, the Python imaging library, that you can use to manipulate images in Python. We need something from the itertools library as well. So we're going to use something called the product. There we go, itertools import product. That's going to allow us to do some multiplication quickly. We need to be able to sample to get a random number of objects. So we're going to use the random library and we're going to use sample from that. And finally, I think this is the last one, just to put a bit of a delay before we quit the program, we're going to use the sleep command from the time library. So we want import sleep. There we go, that should be everything we need. Okay, so we're going to create a class, and I'm just going to call it the same name as the file, so SnakeSpot, and we'll make this a TK application. So we'll use that as the parent of this class, and we might not fill anything else. We'll just put pass in there for the moment, and then we'll put in our idiom down the bottom. So we'll go, get rid of the terminal window. We'll go if underscore name underscore double equals quotes double underscore main double underscore. And then we'll go root equals snake. Oh, I called it SnakeSport. We'll fix that in a second. and root.main loop. And parentheses on the end. So let's right click on SnakeSpotter, change all occurrences, and take out the R. Push enter. Don't push enter. We don't need to do that. There we go. We should have changed all those ones. All right. We're good to go. Let's start creating our game. So the first thing we want to do is define our init function for our class. And the init function here, we will give it a parameter called size. And that's going to be a list, and that's going to be the size of our backyard. So it's going to be 5 blocks wide by 5 blocks high. So each block is a possible location of a snake. So this could have 20, or this will have 25 blocks in it, and there could be a few snakes in those blocks, and we're trying to see if we can find all the ones that aren't snakes without getting bitten by some of the ones that are snakes. So we'll start with that. So we can change that size later if we want, so we can have a bigger backyard with more snakes in it. We'll make our game have that kind of ability. So in the init function, we better call our super, which is our TK object, and all that needs to do really is run. So we just need init, that'll do. And then we'll create our size equals size. We'll just add that in as a class attribute with self.size. And then each one of those blocks, we're just going to call them a tile, because when we play the game, you'll see they look like little tiles. So we'll go self.tiles equals, and this is where we're going to start using sets. So we're going to make that a set, just an empty set at the moment. So to make an empty set, we have to use the set function with parentheses. That's a bit like a list, except instead of square brackets, a set actually uses curly braces. Same as a dictionary does, but it doesn't have any keys. We'll talk about them more in a minute. So we need our configure UI function and our create widgets function. These are the ones we've been making in all our files recently. Okay, so let's just create some functions. So we'll just create them as we always do, and then we'll fill them in afterwards. So the first one we'll create is the configure UI one. And we'll put pass in all of these until we actually are ready to fill them in. Then we'll create then we'll make the create widgets function. And we don't need too many functions, but we do need a few. We're going to try and break this code up. So it's in each function has like a purpose, a logical purpose. So we're not trying to do too much in one function. It's always a good idea not to have like one really big function or that kind of stuff, but to split them up. So we're going to try and split these up into like logical kind of steps, and you'd be able to easily understand when each function should run. That's the aim. See how we go. And we're going to have a function for loading our images. So we'll go, the next function, we'll call it, load images. That'll do. And after that, we'll create a function to get where our snakes are hiding. When we first run the game, it's going to randomly distribute snakes on in our backyard. So this function is the one that'll do that. And then we need something. Then we want to check a tile or check a location, because we're going to check to see if it's empty, and hopefully it is, or maybe there's a snake there and it's going to bite us. So we better create a function, and I think we'll call this one, we're in the backyard, so we'll call this one clear the grass or cut the grass. Yeah, maybe that'll do. Cut grass. So you're cutting grass and hopefully you don't get bitten by a snake. Because if you live in Australia, in some places, you have to watch out in summer because there can be snakes in your backyard. You never know. And some of them are extremely venomous. So the next one is, imagine we're about to cut the grass and we think there's actually a snake there. So we want to mark that location to remind us not to cut that grass. So we want to flag the location. So we're going to have a function to flag where we think a snake is. So we're going to put down that marker to remind us not to step or go in that location. And what else do we need? To make the game like playable, we need to get some hints from the game. Otherwise, we're just randomly clicking on areas and hoping there's no snake there. So we need some hints. And the hint just tells us whether there are snakes nearby or not. So we need a function to work out how many snakes are nearby a particular location. So we'll call that function getHint. That'll tell us whether there's any snakes near that one particular tile, that one location. All right, next we need, well, imagine you've got a Rubik's Cube. You've got 9 squares with 3 by 3 rows. So if you click in the middle one, you've got 1 square around the outside. You've got 8 squares around the outside, I should say. 3 across the top, 2 on the sides, and 3 across the bottom. So we need to know what those locations are. When someone clicks, we need to know what the other locations are around the outside of the one they clicked on. So we're going to call this function the adjacent tiles, because these are the ones that are next to or touching the location that the person clicked on, the player clicked on. Okay, so this function is going to tell us what those tiles are, or which ones they are. And we need a function called showHints. Now this one is going to do most of the work for us. So this one will probably be our last function, I think. Let me think. So we need a location as, and I need to fix a couple of these functions. Okay. So I think that's the last one. Yeah, that's it. So those are the functions we're creating. Now we need to fix a couple of these. We need to fix, where is it? This one? This one, we're going to flag snakes by using the mouse. And this is going to be an event. And when we click the right mouse button, the right mouse click, that's when this function is going to run. So we need to put event in there. Oh, and also for this one too. This is when we click the left mouse button. So this is going to be an event as well. So we need to pass it the event object. When we click the button, that event will have information that we're going to use in our function. So we're going to need that. All right, I think that's it. I think we've got, I can turn that off now. Might make it a bit easier to see. I think we've got everything. Okay, so I guess we can start filling stuff in. We may as well start with the configure UI one. That one's pretty easy to create. So this is an application. It's a TK application. So we can give it a title and a width or a geometry. So let's do that. So self.title, it's a function. So we'll say this is called SnakeSpot. You can put whatever you want in here. Can you spot all the snakes without getting bitten? Hello. That's the aim of the game. And we'll set a geometry, and we won't go too big. We'll just start with 400 by 400. That should be a big enough window. And then what else do we need to do? Oh, we'd better load the images. We've got these, I've got these 2 pictures. So you're going to need 2 pictures. You can download them yourself, whatever pictures you want to use. These are the 2 that I chose. So I'm going to load them at the start and store them so that I can use them as many times as I want. So let's run this function in the configure UI one. Let's call this function. So we'll call self.loadImages. So we'll call that from the configure UI function. Okay, and then while we're here, since we're configuring the UI, we may as well create a style so that we can, set some colors or change some settings for our TTK widgets. So we'll just call it style, and that's going to be a ttk.style belonging to this object. And well, we're in the backyard, so we'll imagine we've got some grass. So let's just set some colors. We'll just use some greens. So we're going to use labels as our grass tiles. So we're going to have little square labels that are going to be the grass. So we'll give them a color. So let's set label color by default. So to set the default label color, we just go self-styled configure, and all the labels have this as their base style, T label. And then we can just set the background color. And I'm going to choose light green because it's grass. That's the grass tile. Okay. And we may as well make the frame that it's going to be in green as well. So we'll just do another self.style.configure line. And this time we'll go T frame. So the default for all frames will be to have a background color of green. Don't need the capitals, I don't think. Here we go. So in other words, all labels will by default have a light green background, and all frames by default will have a green background. That'll do. We'll try that. Okay, that's pretty good. What's the well, let's do the load images one now. That's probably, since we're going to run that function up here, let's finish that function. And this is where we're going to use that pill library, the Python imaging library. So we need to load these two flag and snake images. So let's do that now. So that one there. All right, so to load the images, well, the first thing we'll do is we'll use the OS module to store a path. So we'll go self.path. Oh, we don't really need to save it there. Let's just go path. This can just exist inside the function. os.path.directory name, and then we're going to get the directory that this Python file, this one that we're typing in now, lives in. So we don't have to know where that is. This command is going to tell us where it is. So we do the os.path again, but this time we take the abs path and we give it this funky double underscore file double underscore. So this object here, this file, is this code. So we don't have to know the name of the file that's saved on the hard disk. We can just use this, and that's going to treat it as if it's this code here that's running. So that's going to give us the directory for where this code is that's running right now. So we never need to know where it is. We'll just find it out with that command. Handy. And let's set a default image size. So we'll go a default image size of 20 pixels. So it's just an integer. So we'll just say 20. Okay. So the first thing we're going to do is load the snake. So we'll load image for a snake, and snake equals. So we're going to use the Python imaging library. So that's image.open. And we just need to give it the path, the full path to the file. So it's in the images, and it's in the snake.png. That's what mine's called, isn't it? Yep, there it is. So it's in the images and snake.png. Yeah, and I might change this path too, just because might make it easier. Let's just add to it on the end. So we're going to get where this stuff is going to give us where the code is, the folder for the code, and then we'll add the images as a string to the end of that. So we'll just add that to the end of it, so we don't have to type it in down here. That'll make this bit a little bit easier. Yeah, we'll go with that. Okay, so in here we're just going to open the file, we'll make it an F string, and it's going to be the path in curly braces, because that's going to insert it there, and snake.png. Obviously, if you had a different named image, you'd have to change that name there to whatever you've got in your images folder. Or if you don't have an images folder, you need to adjust this kind of stuff. But for me, that's what I'm using. All right, so we've got that. And then we better make sure, because if you look at this picture is not 20 pixels high. This picture is much bigger than 20 pixels. So we need to resize it. So we'll use the thumbnail. the thumbnail method of an image to resize it. And that just takes, well, the size we want to make it. So we'll go snake.thumbnail, and then we just need to give it a list. And inside that list, we just put image size twice, once for height, once for width. And it'll try and shrink it down into that size. And it'll give you, the picture shrunk down pretty much to that size. Okay, so we've shrunk our picture down, so it's not going to be too big. Now we just need to turn it into something that Tkinter can use, and that's going to be a photo image. So we'll store that in our class. We'll say self.snake equals image tk dot photo image, and just give it snake as the argument in there. So we're going to turn our snake image into a Tkinter photo image so we can use it. All right, that's the snake done. Let's do the same thing for the flag. So load image for a flag. Same thing, so we'll just call this one flag. It's pretty much the same code. Probably could put it in a loop, but for the moment we'll just go with this. So we need our path in there. And this time I've called it flag.png. So flag.png, even though it's not a flag, it's how we flag there's a snake there. So that's why it's called that. And then we need to set the thumbnail, flag.thumbnail, and a list with image size twice. There we go, and then we'll save it to the class. So we'll say self.flag equals image tk dot photo image, and flag goes in between the parentheses. All right, done. We've loaded our two images. Nice. Okay, let's make sure we save that. Okay, so we're well on the way now. We've configured our UI. We loaded our images. What's another nice, easy function we can do now, I wonder? How about well, actually, the easiest thing to do now, you're going to think maybe this doesn't seem so easy, but it is actually going to be easier than you think. Even if we've got 25 labels, normally in Tkinter, for each label, you'd have, label equals tk.label. That's one line of code, and then you'd have to put it on a grid. That's another line of code. But for us, we're only going to do a very small amount of code to lay out all those labels, because we're going to do them inside loops, which is going to make our lives much easier. So let's actually create our widgets, which is going to be a grid of labels, basically. So here we go. Let's get that going. So the first thing we need is a frame, our backyard frame. So let's put in a frame that's going to be the one that holds all those labels, or our grid of labels. So we'll call that self.backyard. And that's going to be a TTK frame. It's going to belong to the main window. So we just put self in there. Now we'll give it a relief, which is going to give it a border. And we'll put in quotes groove, which just kind of makes a line for a border, but we have to also give it a little bit of padding, just so that you can see that, I think. Yeah. So let's put a bit of padding in there. 3 pixels should be enough. You can always change that if you want. And then we need to pack it. So self.pack it in the main window. I mean, you could put it in a grid, but pack's easy. And we may as well make it expand as well. Expand means it'll take up the whole window size. That looks good. Okay, so we've got our backyard. And because we created our style up here, we know that the backyard, the frame, is going to be green as the background color. So that's good. We're going to have a nice green backyard. Nice. It's not usually green here, but in summer, but in this game it will be anyway. All right, so now we've got our backyard frame, we are ready to start creating our tiles. So it's a 5x5 grid of tiles. Each tile is going to be a label. So let's create the tiles. Can't type very well. Where the snakes are hiding. Now we're going to use two loops to do this. So we're going to have what's called a nested loop structure. So the first one, we'll call it the, I guess the X. It's going to be the columns. As you go from, say, left to right and you create a new column, that's like going along the X-axis if you had a graph. So we'll go for X in range, and we'll use that size variable, and we'll treat the first part of size as the X part. So we'll say in square brackets, we'll put 0 in there. So that will give us, by default, we set that to 5. So that will give us a range from 0 to 5, but not including the 5. In other words, that'll give us columns 0, 1, 2, 3, 4. 5 columns, but the index will be 0 to 4. Okay, so we'll do that. And the second loop is going to be Y. And that's going to give us the rows going from the top down. So it's the same thing for rows in range, self.size, but this time we don't want index 0, we want index 1. So index 0 is this 5, and we want index 1 for the rows going down. So it's going to be the columns in the first part, the rows in the second part. And we'll put a colon in there. Okay, so now we've got a loop that's going to run 5 times here and 5 times here. And it's going to create 5 columns, and in each column it's going to create 5 rows. So in each row and column we have a tile. So let's create a tile. So we just go self.tile. That's going to be our label, ttk.label. And we'll put this on a new line so it's easy to read. And what's this going to belong to? It's going to belong to the backyard. Self.backyard. That's going to be its master. And what else do we need to set for the label? We're going to raise it up. We're going to make it appear a bit like a button. So we'll put raised in there for the relief. Do we need anything else? Oh yeah, we want to make sure that any text that appears in it appears in the middle of the label. So we'll go anchor equals, and we want center in there. All right, I think that'll do us. We've got the closing bracket. Yeah, that looks good. Okay, so we've created our label. So now we need to put it in the grid. And the grid coordinates are just the X and the Y. So as the loops run, as each loop runs, we use the X and Y to fill in the row and column for, or the column and the row for each tile. So we go self dot tile dot grid columns equal, or column equals X, row equals Y. So we're just going to use the loop values, and we may as well make it go in the center of the row and the column. So we'll go tk.nsew for sticky. That will put it in the center of the cell, I suppose you might think of it as. Now, what we're also going to do is we're going to keep a record of these X and Y coordinates. We're going to treat that as the location for this tile, because when someone clicks on it, we want to easily know which tile they clicked on. So to do that, we're going to give each tile a location, and we can do that just by creating it. So location doesn't exist, but if we add it to the tile now, it will remember it and it will save it as a new property. And we're going to make it a tuple, or a point, you might think of it, with X, Y. They're the coordinates for our location. So that's going to give us the column and the row where this tile is. So we'll always be able to know which tile was clicked on easily by looking at that location. And then we need to use these two functions, the cut grass and the flag snake. When you click on one of these tiles, if you left click, you're going to cut the grass, and if you right click, you're going to flag it as having a snake there. So we need to bind those two functions to those events. So we do self.tile. Self.tile.bind. and we need to bind button 1. So you need to put these arrows in for these. Button dash 1. That's the left click button. And we need to bind that to the cut grass. Whoops. Cut grass function. And you don't need parentheses when you bind these functions. And the right mouse one, self.bind, same again, quotes, arrows, and this is button 3. Right mouse is button 3, button dash 3, and we're going to bind that one to the self dot, and what did we call it? Flag? Snake. There it is. So now we have bound our labels. So when we left click or right click on them, these functions will run. That's how easy it is to add bindings to run functions when things happen to your objects in Tkinter. It's not too bad. It's pretty good. All right. Oh, and the final thing we need to do, we need to keep a record of, we need to keep a record of all the tiles as we create them. So as each tile is created, we want to store it in our set of tiles that we created up here. So we want to know all the tiles and store them as a set up here. So we need one more line of code in this loop. So now we need to save the tile location to the set of all tiles. All right, and that's just one line of code, self.tiles, that's that set, and you add objects into a set, and we want to add self.tile.location. So it's going to add this tile's location into our set. So that way, once all the tiles are created, we'll have a group with all the known locations for our tiles. Nice. Now, what else do we need to do? That's just about all the widgets done. That's all we need to do to create our widgets pretty much. There's a couple of things. Yeah, there are a couple of things. What we're going to do to make it easier, we're also going to configure in this loop here, we're going to configure our grid. So what's this? This is our grid columns, the X loop, that's our column. So we're going to configure the size of the columns. So we'll just do it this way. We'll do it here. We'll do self.backyard.grid. No, we want column configure. And X is the column, so 0 column, column 1, column 2, column 3, column 4. And we're going to set the min size. And we'll make it 25 pixels. So that way the label will be at least 25 pixels wide. Now we don't want to put the row configuring in here because it'll get repeated every time this loop runs, which will be 25 times. So what we'll do is we'll just create another loop down here for y, same loop, in range self.size, square brackets 1. The difference is this loop will only run 5 times. 5 times, whereas this one here will run 5 times 5. So it'll run 25 times this one. So rather than run it 25 times, we only want to run it 5 times. So we'll do it outside in this new loop. And it's basically the same as the column configure line. It's almost the same as this one, except we use row configure this time. We're going to configure the rows. We're going to configure each row that's 0, 1, 2, 3, 4 in the y variable, and we'll do the same thing, min size equals 25. Okay, and that should configure our grid so we have nice sized labels without having to set any widths or heights on each label. The grid will do it for us, save us a bit of effort. Okay, let's save it, see if it runs. Should check our code every now and then. There we go. We've got a nice grid. Nothing really happens yet if I'm clicking the buttons, but nothing really happens, but we've got a nice light green grid. That looks good. Okay, that's a good start. So we only really wrote 2 lines of code, this one and this one. This is one line, just spread out a bit. And we got all those labels. So we got 25 labels with 2 lines of code. Oh, and a few loops. That's the power of using loops when you've got something like this where you can repeat things quickly. You don't want to write the same code over and over. Just use a loop. Nice. Okay. Well, I tell you what, we set up these ones here, these bindings. How about we fill in some of those functions? How about we do the flag snake one? Because that way we can test out the right click. Yeah, all right, let's do that. So flag snake is a pretty short function. Effectively, what's going to happen is if we right click on one of those labels, we want this to appear. But we might want to turn it off, say we make a mistake. So if we right click again, it gets rid of this image on the label. So we want to be able to turn this picture on or off by right clicking. That's what we're going to do. That's what this function should do for us. Okay, so let's write something like if event.widget, that's the widget that was right clicked, has an image. So we'll go image in square brackets equals nothing. So if it doesn't have an image, we're going to set the image. So this is what happens when right click. So in other words, we're testing to see, does the widget already have an image? And if it doesn't, we're going to set it to that flag image. So we go event.widget. So basically we can just do a quick copy and paste of this bit. So copy and paste equals self.flag. That's that image we loaded up here. So we're going to show that image. If it does have an image, we want to turn it off. So we go else equals and then nothing or an empty string. That'll turn it off. So turn the flag on with this line of code. Turn the flag off with this line of code. Okay, let's save that. All right, let's see if it works. Right click on one of these labels. So each one of these is a label. So let's pick this one. And there's our little flag. And can we turn it off? Yep, we can turn it off. We can turn it on as many as we want. So I'm right clicking on all of these. And there we go. I can turn it off. All right. So our bind event works. That's this one on each label. And our image is loading. So that's good. And we now are turning it on or off with this function. Nice. Okay. What was the other one? Cut grass. Oh, we won't do cut grass yet because that was kind of like one of the final functions. So we need to do some of these other ones first. Let's do this one. Now we've created our labels. Now we've created our grid. We've got these grid. Some of these should have snakes in them. So at the moment, we haven't got any snakes because we haven't filled in this function, the getSnakes function. That's the one that's going to randomly pick some of these labels and put snakes in them. We won't know where they are. It's going to do it at random. So let's create that one. That's actually another use of sets. And this one is, well, the way I think we're going to do it is I think we're going to, depending on the size of our grid, we've got a 5 by 5 grid, so 25 tiles. I think we'll use roughly 10%. So that'd be, let's say 3. 3 of those tiles will have snakes in them. But if you had a bigger grid, 10% of that grid would have snakes in it. So let's use 10% as our starting figure. We can change it later if we want anyway. All right, so let's just write a quick code. So we'll say 10% of tiles will have a snake. Just to remind us what we're doing. Okay, so we're going to create that number. And we're going to do it as a calculation because the grid size might change. And we use the math module or math library, and we use the ceiling function, which is going to round up. So if you had 2.5, ceil would give us back 3. It'll give us a whole number rounded up. Okay, so then we'll just do the self size times, well, we'll calculate the self columns by rows, multiply them together, and then take 10% of that. So we'll do self size 0 times by self dot size 1. That's the rows times the columns. And then we'll multiply all that by 0.1 to give us 10%. And math will round it up for us. So that should give us a number of 3 in this case. 5 by 5 grid would have 3 snakes in it, which doesn't sound like much, but you don't want too many. So if we wanted to, we could bump that up to 20% or 30%, but that would be a lot. We'll stick with 10 at the moment. And then how do we get, well, we want 3 random snakes. We want 3 of these labels at random to be a snake. Maybe this one and this one and this one, or this one, this one, this one. Who knows? How do we do that? Well, this is where we use the sample mod from the random module. The sample function from the random module is what we're going to use. So let's put that in now. And it's not too hard. So we'll say self.snakes. This is our set of snakes. So we're going to make it a set. And we're going to use the sample function. And we don't want to sample a set because a set is an unordered group of objects. Each one can't be repeated in a set. So you can only have one object without any repeated or repetitions of that same object. Like you can't have 2 number 1s in a set. You can only have 1 number 1. So it's great for giving you unique items. But we don't want to sample that. We want to sample something that's a bit more structured. So we're going to turn our set of tiles into a list. So we use the list word there, the keyword, or the list function, and we'll take our self.tiles, that's our set of tiles, and then we need to tell sample how many we want. So we want the number that we created here. That's what we want. So this is going to give us 3 random tiles and make a set of them and keep them in this variable. So that's going to be our variable that stores which of the tiles have snakes in them. And that's it. That should create our random snakes for us, or our snake tiles. All right. I guess we can find that out, can't we? So let's just double check that that one's working. So, well, you know what? It's not going to work because we're never running that function yet. We need to run that function. We haven't actually called it. We've created it, the code for it, but we haven't run it. So where are we going to run it? We're going to run it in our widgets one. That's where we want to put it. Let's put it down here after this grid line. So go back to create widgets. So go back to this one, the create widgets function. And down the bottom of that function, before you get to load images, we're going to put in self.get snakes with parentheses. So maybe a little comment as well. Create the random snakes hiding in our backyard. So we can't create this until after we've worked out what our tiles are. So we have to put it at the end after we've actually created our tiles and we've got all our locations and we've saved them in here. Once we've finished all these loops, then we can create our random snakes, or the locations of our random snakes. Yeah, that should work. So let's just go print self.snakes, which should work now after this function's run. And let's run it and see if it prints out something about the locations of snakes. It should show us 3 locations. Let's see if it does. So we'll click play. And there we go. These are our random snakes. So this is column row. So column 1 is this one. So that one is a snake. Column 4, that one is a snake. And column 3, which is this one, and that one is a snake. So we've got 2 snakes next to each other. So all of these other ones are empty, but those 3 locations would have snakes in them. Okay, that looks good. Don't need that print line anymore. Take that one out. All right. Okay, what functions have we got left? We're almost done. We don't have too much more to go. This one's pretty important, the adjacent tiles, and maybe even the get hint. Yeah, which one should we do first? I think we better do this one first, the adjacent tiles, because this one, the get hint, is going to need this function. It's going to call this function. Yeah, so I think we need this one. So the adjacent tiles, when you click on one of those tiles, it finds the locations of all the 9 tiles around it, including itself. So the 8 tiles around it plus itself. And that's just going to give back all those locations so we can check them. All right, so let's do that. So this location is going to have an XY in it. It's going to be one of these, an XY in brackets, which is, or parentheses, which is called a tuple. So it's got 2 values inside it. So we can actually turn a tuple into 2 separate variables really quickly by just doing x comma y equals location. And that'll split up that tuple and it'll store the individual values in these variables. So now we can use those one at a time without having to type location square bracket 0 or location square brackets 1. Just saves us a bit of typing. All right, so when you click on one of the tiles, you want to get all the locations around it, but you don't want to get ones that are not part of the actual tiles. So how do we do that? So when we click on it, each one has a location, an X and a Y. So to get the ones around it, we can just subtract or add to that X and Y value, and we can get the other 8. So really, we just need to subtract 1 or add 1, and that'll give us, to the X and the Y values, that'll give us the 8 tiles around it. So let's do that. Let's call this possible, the possible tiles. So what we're going to do is we're going to create a set of the possible tiles. We're not sure if they actually exist yet, because say you clicked on, the tile in the top left, that would be 0, 0. If you minus 1 from that, that wouldn't actually exist because there's no tile with a column -1. So these possibles might include that tile or that location, but it doesn't actually exist. So we can throw that away later by filtering our set. So let's do that. So the possibles is going to be using the product function from itertools. And we're going to use range. Now we want x -1. That'll give us the tile 1 column before, and we want the tile 1 column after. So that'll be x plus 2, because range is up to but not including the 2. So that would give us, that'll give us the column before and the column after, the one that we clicked on. And product takes a second value, which is going to be another range, and this is going to be the y value, so the row value. So we want the row above and the row below the one we clicked on. So we want y -1, that'll be the row above, and y plus 2, that'll be the row below. And that's enough. That'll give us all the coordinates that we need. And then we just need to exclude the ones that don't actually exist. So the ones that are negative, or the ones that are bigger than the size of our grid, like outside the edges of our grid, you might think of. So how do we do that? Well, that's where sets really make our life easy, because we can compare the possible locations that we've just created, these ones, all of these ones, and see if they actually exist in our tiles, the other set. So by using the ampersand here, we can see if they are existing. So the ones we just generated, based on which tile we clicked on, and then the ones that we know are the real ones here. So this will only give us back the ones that exist. It'll filter out the ones that are outside the edges of our grid. That'll make it perfect. If you don't understand how this works, you might want to put in a breakpoint somewhere in here and run the code. And when you run this function, you just have a look at what's being stored in all these different values and see if you can work out how the code's working. It's always a good idea to debug your code and just get a good understanding of what's being created and what's happening as you run through loops and that kind of stuff. All right, so now we've created this one. We've only got a couple of functions to go. Cut grass, show hints, and this one, get hint. Let's do this one, the get hint function, because this is easy. We just go tiles equals, and we need to find the adjacent tiles. So in other words, when we click on a label or a tile, we need to see if it has a snake near it, or if it has a snake indeed underneath it on one of the tiles that are next to the one we clicked on. So to do that, we're going to show hints, the number of snakes that are around it. So let's do tiles equals self dot, and we're going to run that function, get adjacent tiles, and we are going to give it the location. And actually, this one, we need a location in here too, don't we? So the get hint, we need a location, self comma location. And then, so yeah, those two need to look the same. That's right. We need to pass the location through to the get adjacent tiles function. And what are we going to return? We're going to return the number of tiles that are also in our set of snakes, that are also in the random set of snakes that we created up here. So we stored those in that set. So we're going to use that now here. So we're going to do len tiles, which is these ones, and or ampersand self dot snakes. So in other words, this is going to give the number of these tiles that are around the ones you clicked, or around the one that you're checking, and if any of those have snakes in them, it's going to add them up and tell you how many snakes are around that one. So that'll give us a number. You'll see when we run the game in a second. That'll do. That's all we need for that one. That'll give us the hints. Okay, so what are we up to? I think we're up to... I think we can do... Well, I think we may as well go in order. So we'll do this one next. This is the one that has a lot of the logic in it. So imagine you've clicked on a tile. Let's run our board. We can right click, but let's say we left click now. When we left click, if there's no snake on this tile, on whichever tile we click on, it should remove the tile. It should show us the backyard because we cut the grass and there wasn't a snake there, so we didn't get bitten by a snake. But when we click this one, or this one, or this one, it's going to check the tiles around it. So if this one has no snakes in it, it's also going to tell you if this one has no snakes in it. And if it doesn't, there's no snakes in this one, it's going to remove that one as well. Because when we cut the grass, it's going to cut all the grass that's next to it if it's empty. But maybe this one has a snake near it. So maybe it has a snake in it, or maybe it has a snake here, or a snake here, or a snake here. If that's the case, then this one is just going to show us a number with how many snakes are around it. So we'll cut this one, the grass will disappear, but this one will have a number in it, and this one will have a number in it, and this one will have a number in it, if there's any snakes around them. If there's no snakes around them, if none of the tiles touching them have a snake in them, it's going to remove them. It's going to cut the grass. So that's what this function is going to do. It's going to show those numbers or cut the grass for us, or remove the grass if there's no snakes there. So we need to, first of all, when you run this function, this location is the tile that you clicked on. So now we need to find the tiles that are around it. So we can use our get adjacent tiles function again. So we go tiles equals self dot get adjacent tiles. We send it the location. that we clicked on, which is this one here. And that's going to give us the tiles that are around the one we clicked on, plus the one we clicked on. So 9 tiles in total, or up to 9 tiles. Then we need to go through each tile one at a time. And it doesn't matter the order that we go through, we just need to go through them. So we go 4T in tiles. That's for, if we've got 9 tiles, we go through each one. And as we go through each one, we're going to save the tile that we're actually looking at right now in that variable T. And now we can check the label that's in this location. So we've got a location here, which is an XY coordinate. How do we get the actual label object? How do we get the label, the TK label? Because we can't call it by name because we don't know what its name is or anything like that. Well, here's where we can use some helpful Tkinter things to return the label for each location. So we can use this. We can use widgets, or the widget, the label widget, and then we're going to go self.backyard dot grid slaves, and the grid slaves will give us any widget that is in a particular grid location. And we know what the X and Y coordinates are because they're the location for this tile. So we can just tell it those X and Y coordinates, which are column and row coordinates, and then we can get back the widgets. So we can go column, ooh, that's better, column equals, and it's going to be, that's just a value, X and Y in parentheses. So it's going to be, the column is going to be T0. So T square bracket 0. That's going to give us the X value for the location. And the row is going to be T1. So that's going to give us back any widgets that are stored on the grid of our frame, our backyard frame, in this column and this row. And when we cut the grass, there'll be no widget in that column and row. But if we haven't cut that grass, there'll be a label widget. So we can now check that widget. But we better just make sure that it exists, because if we cut the grass, there's nothing there. So there's no widgets. So we better go if len widgets equals 0, double equals. And we don't want to do anything because there's no grass there. So we don't need to check it if there's no grass. We've already checked it probably, or we've already cut the grass there. But what happens if there is a widget? So it'll be a label. What happens if one of those labels is still there? So we'll just store it as our widget that we want to then do something with. So we'll go widget equals widgets, and it's the first one of the widgets, because there should only be one widget in this column and this row. So we take it and store it in a new variable, just so we can make it easier to type. All right, and now we need to find out if that widget has any snakes around it. So we go, we'll call that the hint. And we go self.getHint, that function we created. And we tell it the widget's location, which means the grid location, or the XY coordinates for this widget, this label. And that's going to work out whether there's any snakes around that label. So 3 things can happen. The first thing that can happen is if we click on this and we get to this function, there's no snake here. We know there's no snake here because if there was a snake here, we'd already have been bitten and the game would finish. So we know there's no snake. So in other words, if this widget is equal to the location we clicked on, we don't need to check anything. We can just get rid of the label. We can cut the grass, so to speak. So if the widget's location equals this location, which is the one we clicked on, then we can just forget the label. So by forgetting it, we can not delete it. Doesn't delete it. What it actually does is it sort of stops it from displaying in the grid. So the grid kind of, it takes it out of the grid, you might say. But it still actually exists, it just isn't displayed anywhere and isn't part of the grid anymore. Okay, so we click on that tile gets removed. That's what we've just done so far. What happens, however, if it's not the tile we clicked on that we're checking, but we're checking one of the tiles around it? Well, when we click on it and the tiles around it also get checked, and if that tile also doesn't have any snakes near it, which would be hint equals 0, there's no snakes near that tile, then that tile will get removed as well. So we can do grid forget again. However, when you remove that tile, you then have to go and check all the tiles around that one. And then if you remove more tiles, you have to check the tiles around those ones as well. So rather than running lots of extra lines of code, what we're going to do is what's called recursion. We're just going to call this function again, and we're going to call it with this new location, the one that we just worked out we're also removing. So to do that, we just call the function again, self.showHints, and we just put the widget location in here. So as we remove each tile, if we remove one that isn't the one we clicked on, we go back and rerun this function and check all the tiles around it. And if we remove any of those, we check all of those. And if we remove any of those, we check until, so with one click, we could end up removing lots of tiles if they don't have any snakes around them. Cut lots of grass. Okay, and if there is a snake around a tile, and it's going to have a hint, a number of tell you how many snakes there are, you don't remove it, you just display the number. So we don't want to forget these ones, we just want to display the number. So we go widget.config or configure, same thing, and text equals, and the text is the hint, the one up here that tells us how many snakes are near that tile. Or it could actually be there's a snake on that tile, but we don't know. But it'll tell us if there's 1, 2, 3, 4, 5, 6, 7 snakes near that tile. Okay, that's it. We don't need anything else for that one. One function left to go. This one's easy. This is our left click function. So right now, if we run our code, we can right click, but left click still doesn't do anything because that's our cut grass function. That's what happens when we left click on a label. So let's fill that one in and we'll have made our game. We're almost finished. So what do we need to do? Well, if we click and there is a snake there, well, you've been bitten by a snake and that's the end of the game. You lost the game. So let's do that. Let's go if, so the place that we clicked is going to be the event widget. So if the event widget, and each widget, each label has a location. So if that location, the XY coordinate, if that location is in self.snakes, we know there's a snake under that label. And so we can show that snake. Back to the player, which is, we can just copy and paste this code. Event widget image equals, but we don't want self.flag, we want self.snake. There we go. So if the person clicks on a label and that location is in our randomly generated set of snake locations, display the snake image. That'll do. Let's just test that out, see if that does anything. So let's click all the cells until we find, there's one. We found a snake and the image. Oh, there's another snake. So there's one more snake somewhere. Let's see if we can find it. Just click on them all. Where was the other randomly generated ones? There he is up there. So there's our 3 snakes. Let's just make sure that's random. Let's try again. One last time. Click. There's one different location. That's looking good. They're not all next to each other so far this time. Might not have clicked on all those cells. There's another one. Oh, there's still a few next to each other. Doesn't necessarily see random. One last time. Well, that one's different. This one's... We're still getting a lot of twos together, but I think it is random. It's certainly not in the same location every time. So we'll assume it's random for the moment. Okay, so if someone clicks and they see the snake, they've lost the game. So we may as well put in a bit more information. So we're going to do this self update idle tasks. That's going to make sure that the picture of the snake displays back to the user. And then just for now, like you might want to do all kinds of things like show a message box or, play a sound or do something to indicate that the user has just lost the game or the player's just lost the game. But I'm just going to print out some messages for the moment. So we'll say, oh no, you were bitten by a snake. Yeah, we'll print out something else. We'll say, whoops, put it in quotes. You had better get to the hospital. Okay. And we'll sleep for a bit. We'll use the sleep module and we'll sleep for say 5 seconds. No, it's too long. We'll sleep for 3 seconds and then we'll quit the game. And we can do that just by typing self.quit with parentheses. So let's see if that works this time. So we'll run it. So we should see these things print out in the terminal. If we hit a snake, there's one. It said that, and it's paused, and it quit. Awesome, it worked. Okay. All right, so that's what happens if they click on a tile and it has a snake in it. But what happens if they click on a tile and it doesn't have a snake in it? Well, that's where we should be cutting the grass. We should be removing the tiles. So we need an else. That's not how you type else. There we go. And in this else, we only need one line of code. And that is to run our show hints function with the location that the person clicked on, which is the event widget location. So in other words, we know there is no snake now. So we just need to cut the grass and show the numbers if there are any snakes around it. So we go, what do? We do self.showHints, and inside the show hints, we put the event.widget.location. That's it. I think we're finished. I think we'll be able to play a game now, and you'll be able to see how it works. Let's try it out and see. So we'll run it. Okay, let's click on a cell. Now, if we click on it, the label, and there's no snake, the label should disappear. So the first one, you never know where the snakes are. So we have to pick, I guess, randomly, but hopefully carefully. I like to go for the corners. There we go. There's no snake. Oh, and we cut the grass, and it told us that these tiles here have one snake somewhere around them. It could be this tile that has a snake on it, or it could be this one, or this one, or this one, or this one. So for this one, it could be any of these tiles around here could have the snake in it. We don't know about these ones. So I'm going to pick one from somewhere over here, I think. I'm going to pick this one. Okay, that got rid of a few. All right, but still no easy ones. How about this one? How about this one? Okay, so all the corners are gone. So let's see. Are there any obvious snakes anywhere? Well, we've got one here. Not yet. Still a bit hard to work out what's going on. I think I might pick this one. Okay, I reckon that one's clear. I think that one's clear. How about this one? Oh, still no snake. One there. Oh, I think I'm going to hit a snake. It's not easy, this one. All the snakes are spread out, I think. Let's see. How about this one? This one. Oh, no, I got one. Too bad. I failed. But the game worked. 5 by 5 is a small grid. I tell you what, let's make it a bit bigger. So we can do that. We can either go back up here to the very top of our class and change this number, but that's the default size. So rather than change the default size, let's leave that. And let's go down to our root object and let's change the size down in here. So let's make it well, let's go for something simple like, we'll go for 10 by 10. There we go. Well, it doesn't have to be square. Let's make it 10 by 12. There we go. Now we've got 10 columns by 12 rows. Now that's a bit bigger. Let's see what happens when we click one of these. We'll click here. Click. Oh, look at that. It recursively went and removed all the empty ones and updated all the edges that are next to those with the number of snakes. That looks good. That's working well. Ah, oh, and I did have to pick somewhere that had a snake. Let's try again. Oh, look at that. All the snakes are pretty close to each other in here. So we can tell that because this one here is by itself, it's either this one or this one that has a snake in it. So one of these has a snake in it. Or this one itself has a snake in it. Could be this one too. No easy ones there. No, no, no. Probably that one is a snake. I'm going to click on this one, but let's see. Yeah, there you go, it was. So that one was a snake. There you go. So that's our game of snake spotting, which is a minesweeper style clone. Now, if you were really playing this game, you'd probably want to add a few more bits and pieces into it, because at the moment I can put down as many flags as I want, which is probably not what you want to do. You probably want to limit the flags to the number of snakes. So you know how many snakes there are because we calculated it here. So you should probably work out a way to limit the number of flags and maybe have a label down here that shows people how many flags they've got left, shows the player. And maybe you want a time limit or some kind of score. And maybe you want a header up the top here or some other kind of variations. You can add all that in as much as you like. But at the moment, you can play the game, but it doesn't really, give the player much help. It doesn't tell them what to do. They just have to work it out for themselves. So you probably need to do a little bit of adjusting to get this to be a sort of a more finished game. But I think for now, that's where we're going to finish it off because this video is long enough already. Thanks for watching. Good luck with it. Hopefully you managed to get it all working because it's quite fun to do that kind of activity, that kind of uh, application to build that one. Hopefully you enjoyed it. See you in the next video.